Let's take a minute and look at z-scores. And they're explained in Chapter 19, but there are a few things that I'd like to show you just in case you want more information. This is an optional video. I've taken our sample data set and I've come in and I've copied the homeschool post-test onto sheet 2. Here it is. Now, if you look in Chapter 19 on page 537, the formula for z-score is the raw score minus the mean and then divided by the standard deviation. So before I can calculate my z-score, I need to figure out what is the mean. I'm going to use my formula bar, use my average right here, and I'm going to look at the average of these 20 scores. Okay, and it looks like my mean is 19.35. Now I'm going to go into my formula bar and I'm going to look for my standard deviation. It looks like I need to get into my statistical menu here, and this should be very familiar to you now, probably more familiar than you ever hoped. Okay, standard deviation of a sample. Because this is a sample, I'll click OK, and I'll tell Excel that I'm using these 20 data points. And here's my standard deviation, 9.34. So now I'm going to actually type a formula into row B. In Excel, a formula starts with equals. I'm going to say that this equals, with a parenthesis, this number, my raw score, minus this number, my mean. And then I'm going to put a parenthesis around this. Now I need to put dollar signs in with my mean here. And that's because I'm going to want to scroll down and use this formula for every one of these post-test scores. And it won't work for me unless I tell Excel not to scroll down when it's looking at the mean. Now here I've got divided through by, and here I've got my standard deviation. And once again, I'll put dollar signs in here so that I stay fixed on that cell. Okay, so here's my formula. Let's see, what is the z-score for a post-test score of 11? It's negative 0.89. I'm going to grab the little box in the corner and bring it all the way down. And now I have a z-score for every student score. If you remember, and let's talk about how to interpret these, a z-score can be interpreted as the number of standard deviations below or above the average. So a test score of 11 is almost one standard deviation below the average. And the reason we know it's below is because it's negative. Look at this. A test score of 44 is 2.6 standard deviations above the mean. Generally, if we see anything more than 2 standard deviations below or more than 2 standard deviations above, we say that those scores are very significant, possibly outliers, and definitely worth paying attention to. So just make this a little bit bigger. If you look at my column here, you'll see that the only score that's either 2 standard deviations below or 2 standard deviations above is this score of a 44 on that post-test. There are some that are close. Let's see. Well, a 31. I guess it's not that close. Yeah, that 44, that's the score to pay attention to. So turn back in your book to the chart on page 534 that shows percentile ranks. This also shows at the bottom of the graph there's a mean. There's 1 standard deviation, 2 standard deviations, 3 standard deviations. Well, 2 standard deviations above the mean is about a 98th percentile. Do you see if you come down the graph, the z-score is 2, the percentile is 98, and then they have an IQ score, a corresponding IQ, and a corresponding SAT score. If I wanted to look at this score of 2.6 and say, what is the percentile? I could look in that graph to somewhere right about in the middle of the 2 standard deviations and the 3 standard deviations. And I could guess that maybe there's 1% above and 1.15% below. I might guess that this is the 99th percentile. It's probably even a little bit higher. What this means is that 99% of the students who take this post-test should score below a 2.6. Now, if I looked at this, let's say that this 11 is about a -1. I'm going to round it to a -1. If I want to know the percent of students who score below this score of 11, I could add all the percentages in my graph and come up with the percent. So it's 13.59 plus 2.15 plus 0.13, and I could say that, let's just do it professionally here and make sure we've got it right, equals the sum of these 3 numbers right here. Oh, excuse me, I'm making this harder than it has to be. Okay, my most recently used, my sum. There we go. Okay, so here's my sum of E6 to E8, and the number is 15.87. So if my student scores an 11 on the post-test, only about 15% of the students score below that, meaning he is in the 15th or the 16th, in this case, percentile. Percentile doesn't mean the percent of students who score above, but if we rounded this to 16, let's say that this score is in the 16th percentile, and I asked you what percent of students scored above, I could find that by taking 100 minus the 16, and I would tell you that 84% of the students score higher than an 11. And these are all averages, these are general rules, but these give you a sense of how z-scores and percentiles can be so helpful. Now here's a tricky question. What if I asked you what percent of students score between a z-score of -1 and a z-score of +1? If you look at your graph, you'll see that if you go from -1 standard deviation to +1 standard deviation, there are 2 boxes, each with 34.13% of the potential responses, meaning that 68.26% of our students should score between a -1 and a 1 z-score. Notice that that's much higher than, say, if I asked what percent of students score between a -3 and a -1. And that's because of this bell-shaped curve. It has to do with how much of that gray area is in between the lines on this curve, and between -1 z-score and a +1 z-score, that's where most of our scores are, and that's why the curve peaks at that point. That's why it's a mountain there. When we get out to the tails, so we get lower than a -3 or higher than a z-score of +3, the percentages are so small, only 0.13% score below that -3 and only 0.13% score above the positive 3. Hopefully this gives you a sense of what z-scores mean, how they're used, how they correspond with percentiles. Get in there and practice just a little bit. Talk yourself through it. You don't have to memorize this, but if you're really familiar with it, then you'll feel comfortable with the question that's on the quiz. This is some of the tougher stuff that we do mathematically. Thanks for hanging in there with me.